So in this video, we're going to be discussing two-factor problems, how to solve problems that are two factors. So if you look at this problem, it says the physician orders a medication at 8 milligrams per kilogram by mouth twice a day. What's available, the medication on hand, is 140 milligrams in 10 milliliters. The child weighs 12 kilograms. What will you give that child? So two-factor problems, when we're using dimensional analysis, we always have to identify the given. So in this two-factor problem, we start with the ordered dose of the medication. And that ordered dose, that strength, is the numerator. And the weight, which is kilograms, is the denominator. So in this case, the physician ordered 8 milligrams per kilogram. And that's how we start our problem, with the given. And that's the ordered dose and weight. So 8 milligrams per kilogram. What is our wanted? Well, how do we figure out our wanted? Well, what's available? That's how we figure out what our wanted is. And available is a liquid because it comes in 10 milliliters. So we have to figure out milliliters. And I always put that over 1 because this reminds me that I need milliliters in my numerator. So how do I get there? I've got a lot of information in my question, and I totally encourage you to do whatever works for you. You can highlight what you've used, cross out what you've used. Well, I've already used this in my problem. That was my given. So my wanted is milliliters because that's what's available. So how do I get rid of milligrams and kilograms to get a milliliter? Well, I use what's available in my problem, and I have to start with what's on hand, what's available. So I set things up so I can cross off the unwanted. So if I want to get rid of milligrams, I can use the on hand, but I have to make sure I set it up so I can cross off my unwanted. And in this case, I'm going to put 140 milligrams in the denominator position and 10 milliliters in my numerator position. When I do this, I can cross off my milligrams. Well, I'm almost there because now I have my milliliters, but I still have to get rid of kilograms. So again, I've used this. So what else can I use in my problem to get rid of kilograms? Well, I have the weight of the child. And I set this up in my numerator. I can put that over 1, and that crosses off my kilograms. So now I look at my problem. I've gotten rid of all of my unwanted units. I'm left with my wanted. And now it's just math. So when I say 8 times 10 times 12, that will give me 960. 140 times 1 is 140. When I divide 140 into 960, it will give me 6.8571. I have to remember my rounding rules. 1 to 10, I round to the tenths. And 5 and higher, I round up. So my answer, what will you give? I will give this child 6.9 milliliters. And that's all I write on my answer line. So here's another example of a two-factor medication problem. And how do I know that? Because the order has 2 parts. So the recommended dose of an oral liquid medication is 0.4 milligrams per kilogram. And that's to be given QID, which is 4 times a day, for a patient that weighs 105 pounds. What am I going to administer? Well, we set up our problems with the given, and the given is 2 parts. 0.4 milligrams over kilogram, the weight. What is my wanted? Well, I don't have much information in this question. I have a couple things that I could circle and point out. But what am I going to administer? Well, what I do know, it's an oral liquid. But it's asking for the recommended dose of an oral liquid. So I'm solving for a dose, strength. So I'm solving for milligrams because that's what I have available, milligrams. So using this setup, I have 0.4 milligrams and I have milligrams as my wanted. So that's great. I have the first part done, but now I have to get rid of my kilograms. So how do I do that? I use what's in my problem. But I automatically recognize that I need to convert pounds to kilograms. So I know that 1 kilogram is equal to 2.2 pounds. I can use this conversion in my problem to get rid of kilograms. So that gets rid of my kilograms, but now I have to look to get rid of my pounds. And how do I do that? Again, I look to my problem, 105 pounds. I can put that over 1. That gets rid of my pounds. So now as I'm looking at my setup and what I've crossed off, all of my unwanted is gone and I'm left with milligrams, and that's exactly what's wanted. So now it's just math. 0.4 times 1 times 105 is 42. And 2.2 times 1 is 2.2. And when I do that math, it gives me 19.09. And anything over 10, I round to the whole number. So 19, 0 is less than 5. So I'm going to keep it at 19. So I'm going to administer 19 milligrams. And that is what I'm putting on my answer line. So if you look at this problem, and I encourage you to pause this video so you can try to figure it out on your own after we did the first two. But pause it now so you don't see me doing it, and then come back and see if you got it right. But the NP orders Phenergan 0.5 milligrams per kilogram IV every 6 hours as needed for nausea. So when I see it written out, it still means 0.7 milligrams per kilogram. And these are how doctors write or practitioners write orders. It's telling us how much, how we're giving it, how often, is it on scheduled hourly or every 6 hours, or is it as needed? And in this case, this one is as needed. But it's information that I don't need to worry about in my calculating my problems and solving my problems. So my given is, if I wanted to write it out, given is 0.7 milligrams per kilogram. That's my order. On hand is 35 milligrams per ml. The patient weighs 75 pounds. What am I going to prepare? Well, let's think about this. What is my wanted? Well, if it's available in milliliters, that's my wanted. So some people like to start their wanted with their wanted first, and neither is wrong. You just have to make sure that where you start and where you end is the right setup. So 2 factors, we start with the order, but we put the dose on top in the numerator position and the weight ordered on the bottom. So the doctor wants 0.7 milligrams per kilogram, but I have to get to milliliters. So again, if you want to cross things off as you use them, go for it. So now, how am I going to get milligrams to milliliters? Well, I got to look at my problem. And what can I use to cross off my milligrams? Because I have to put milligrams down here to get rid of it. Well, I go to my problem. There's 35 milligrams in 1 milliliter. That gets rid of my milligrams. And look, I have my milliliter, but I still have this kilogram hanging out there. So what can I use in my problem? I've already used this. I've already used this. Well, I have weight, but my weight is in pounds. So I know I need a conversion. So I know that 1 kilogram is equal to 2.2 pounds. So I can use that in my problem. I can use my conversion. 1 kilogram is equal to 2.2 pounds. That gets rid of my kilograms, but now I'm stuck with pounds. I have to get rid of pounds because I only want milliliters in my numerator position. So what do I use? I use what's in my problem. The patient weighs 75 pounds. I can put that over 1, and that gets rid of pounds. So as I look at my problem, I've used everything that I need to be set up into my problem. I got rid of all my unwanted, and I have only my wanted. So now it's just math. So 0.7 times 1 times 75 is 52.5, and 35 times 2.2 is 77. And when I divide 77 into 2.5, that gives me 0.6818. My rounding rules, which is available on the front of your tests under the directions, my rounding rules for less than 1, I round to the hundredths place. 1 is less than 5, so I don't round up. So my answer is 0.68 milliliters. Don't forget your units of measure, and don't forget a 0 before your decimal point, because we don't want somebody to misinterpret this as 68 milliliters instead of 0.6 milliliters. That could be a deadly med error. So in this problem, the doctor orders 8.5 milligrams per kilogram, IV every 8 hours. That's intravenously. What's available, dose on hand, means maybe that's what pharmacy delivered, or that's what's in the patient's home if you're working home care. So I have an order, the given. I have what's available, dose on hand, and I have a weight. So what am I preparing? So my given is the 8.5 milligrams per kilogram. 8.5 milligrams. Kilograms in my denominator position. But what am I solving for? Well, what's available is a liquid, so I'm solving for milliliters. So again, our goal is to get rid of the unwanted and get to the wanted. So I have to figure out how am I going to get milliliters in my numerator and get rid of milligrams and kilograms. So I look to my problem. I've already used this. So I can use what's available, 40 milligrams in 2 mLs. That gets rid of my milligrams, and I have milliliters, but I also have a kilogram to get rid of. The weight is in pounds, so I have to remember 1 kilogram is equal to 2.2 pounds. And I can use this in my conversion. 1 kilogram is 2.2 pounds. That gets rid of kilograms, and now I have to get rid of pounds. So it's like this puzzle you're trying to set up. So I've used this conversion, and now what can I use in my problem? The patient's weight. And I have to put it up here so I can cross off diagonally the pounds. So now as I look, I have exactly what is wanted and nothing else. So yeah, you know it. Now it's just math. So when I do the math, 8.5 times 2 times 95 gives me 1615. And 40 times 2.2 is 88. When I divide 88 into 1615, it gives me 18.352. And anything greater than 10, I round to the whole number. So 3 is less than 5, so I do not need to round up. So the answer is I'm going to give 18 milliliters. Okay, for the last one, pause it here if you want to give it a shot, all right? So here's our problem. Prescribed is a medication 5 milligrams per kilogram. So that means it's 5 milligrams per kilogram. That's our given. That's the order. And they're going to give it IV every 24 hours. Available 1 gram in 10 milliliters. So I've got 5 milligrams per kilogram, 1 gram in 10 milliliters, and the patient weighs 88 pounds. So right away I'm looking, I got conversions to do. So what am I solving for? Well, it comes in milliliters. It didn't say what strength, what dose. It's just saying, what am I going to give? Well, the only thing I can give is a liquid because it comes in milliliters. So I put my milliliters over 1. So that reminds me I need milliliters in my numerator position. I start with the given, which is the doctor's order, 5 milligrams per kilogram. Cross that off. So how do I get there? Well, I have available grams and prescribed milligrams. So when I look at that, I have to remember 1 gram is equal to 1,000 milligrams. So I can use that right now in my conversion. I can say 1 gram is 1,000 milligrams. And I set it up this way. Why? So I can cross off diagonally. Well, now I have grams and kilograms, and I still don't have milliliters. So what do I use? I use what's in my problem. 1 gram in 10 milliliters. So I can cross off that I used that. And this gets rid of my grams. And look, I'm almost there. I got milliliters, but I got to get rid of kilograms. The patient's weight is in pounds. So 1 kilogram is equal to 2.2 pounds. And I use that in my problem. 1 kilogram, 2.2 pounds. And that gets rid of my kilograms, but here I go again, I got pounds. So what do I use? I use what's in my problem, 88 pounds. Put that over 1, that gets rid of pounds. Now I check out my problem. I have just the milliliters I need. Now it's just math. So when I do 5 times 10 times 88, it's 4,400, I hope. And then 1,000 times 2.2 is 2,200. And when I divide 2,200 into 4,400, it gives me 2. And I'm going to not forget my unit of measure. So I'm going to give 2 milliliters of medication to that patient.